Physicists think that the universe started with a gigantic event called the Big Bang, which occurred around 13.7 billion years ago. This was the beginning of all that we see today. But one of the greatest mysteries still remains: why did this explosion occur, and what triggered it? Scientists have spent huge amounts of research over the years trying to figure out the science and history behind the universe. The Big Bang theory has been the most accepted explanation, backed by enormous amounts of data and research work by millions of scientists. One of the most important features of this theory is the presence of dark energy, an invisible, widespread force thought to be responsible for the ongoing expansion of the universe since its beginning. Science never stops changing. With the aid of new technologies, such as the James Webb Space Telescope, JWST, long-standing theories are coming under scrutiny. Just recently, JWST spotted more than 750 new galaxies that contradict what scientists predicted, which has opened up new debates and theories. These findings have called into question the Big Bang and the basis of current cosmology. Influential voices such as Michioku have even posited that we are witnessing the collapse of the Big Bang theory itself. We'd like to welcome you aboard for a trip to the outermost reaches of the observable universe to discover more about these new galaxies and what they can tell us about the universe. If you're interested in space and you want to know about the newest discoveries, don't forget to subscribe to this channel, hit the like button, share it, and activate notifications so that you won't miss anything. The pictures taken by the James Webb Space Telescope are stunning, featuring hundreds of galaxies in one image with jaw-dropping detail and beauty. To the public, they are breathtaking, but to scientists, they also bring some surprises. Most of the galaxies observed are more numerous, smaller, and older than anticipated by existing models. Their form and behavior defy expectations, leading to real alarm among scientists. Indeed, the gravity of the matter is itself mirrored in scholarly articles where the term panic is used as a title. The Big Bang theory has been the main explanation for the creation of the universe for decades. It theorizes that the universe came into being 13.7 billion years ago from some enigmatic event. But the newly released images from JWST are redefining our knowledge. These galaxies look too dense, too rounded, and too ancient to fit the Big Bang theory. What's more unexpected is that they are 2 to 3 times less massive than similar galaxies that were seen before using the Hubble Space Telescope, which contradicts expectations based on an expanding universe. As per the current models, when the universe expands, faraway objects should look larger. But what these new findings reveal are galaxies that don't follow that. Even more mystifying is their smooth texture. The Big Bang model predicts irregular, chaotic shapes in young galaxies, sculpted by cosmic crashes and turbulent formation processes. But the galaxies observed by JWST are well-shaped and free of the complexity scientists anticipated. This challenges our timeline of galaxy formation and contradicts the very sequence of cosmic evolution. In the universe's earliest moments, everything that is matter and energy was packed into an unimaginably dense point referred to as a singularity. This concept, based on Einstein's general relativity, accounts for a time when density and temperature become so extreme that they exceed anything that can be observed today. All the universe's ingredients were held in a space so small, it is impossible to comprehend, within the singularity. Out of this extreme heat and energy, the universe emerged. After the singularity, the universe underwent a fast expansion called cosmic inflation, expanding faster than the speed of light. This expansion smoothed out irregularities, making way for matter to spread evenly, finally making it possible for galaxies, stars, and other cosmic structures to form. While inflation occurred fast, the universe has been expanding ever since, something we've noticed by the redshift of light from far-off galaxies. As the universe expands, light waves get stretched, moving towards the red part of the spectrum. In the early cosmos, matter was tightly packed, but as it expanded, it cooled. This cooling enabled particles such as protons, neutrons, and electrons to coalesce and interact with energy, resulting in the formation of matter through a process called nucleosynthesis. Scientists anticipated seeing disordered galaxies sculpted by successive mergers and collisions, but the JWST has another story to tell. Its pictures show neatly ordered spiral and disk galaxies, structures we believed only emerged much later. This finding contradicts the notion that mergers were a frequent occurrence during early galaxy evolution. If such galaxies did not have many collisions, they could never have started small. This is a direct contradiction of the notion that galaxies increase in size over time as a result of mergers. Moreover, visual effects of an expanding universe in which distant objects are smaller don't match what JWST has revealed. This casts serious reservations on our present cosmological models. Lastly, the age and number of such galaxies also pose a challenge to the Big Bang theory. With JWST's sophisticated infrared filters, astronomers are able to study light coming from faraway galaxies to gauge their age and makeup. This measurement indicates that galaxies existed much longer ago than previously thought. All in all, these discoveries could indicate that we will have to undergo a major revision of what we know about the universe. All the matter that comprises our universe was squeezed into a volume so tiny during the expansion. It was obvious that matter could not exist in such a small volume. So changes took place as the universe expanded and cooled down. Particles like protons, neutrons, and electrons started to interact with the surrounding light and energy. These collisions were responsible for the creation of matter in the universe in a span of a few minutes after the Big Bang. It goes by the name nucleosynthesis. Disrupted and turbulent galaxies as a result of many collisions were to be seen, but the JWST images indicate otherwise. In place of chaotic galaxies, we see well-aligned disks and spiral structures like those galaxies we find in the modern universe. Such an observation calls into question the belief that galaxy mergers are a ubiquitous process in galaxy evolution. If these new galaxies haven't had many or any mergers, it is not probable that small galaxies will increase and become hundreds of times bigger as predicted. This means that these galaxies were never small in the first place. Also, the optical illusion that the expanding universe theory predicts when objects look smaller because of expansion is not applicable in this instance either. So, whatever we had assumed till now has turned out to be untrue. Also, the age and richness of galaxies uncovered by the James Webb Space Telescope proved that the Big Bang theory was no longer valid. The JWST is also equipped with filters with which imaging in the infrared region of the spectrum is possible, making it easier for astronomers to examine the colors of distant galaxies. From the colors, astronomers can estimate the ages of galaxies and stars. I hope you enjoyed this video. If you did, don't forget to like this video, share this video to reach more individuals, and subscribe to the channel so you won't miss our next videos.